Hi, John.
Hello, how are you?
I'm good.
Excellent.
So are you going to use slides?
I am. I live by slides.
So you should be able to share the screen.
Perfect. Excellent. Thank you.
We'll be starting in just a minute or so.
All right.
People are showing up. That's good.
Yeah, I just sent the link out on the Slack channel I maintain. So, of
Oh, great. This,
course, have to have our AI
yeah.
attend. Hey, Jim
Jim is here. Gary.
and Alec. Hey, everyone.
John Saw is
Hi,
here.
John. Hi, everyone.
John, doing great, man.
Michael.
Oh, Deshaun, coming to give me grief.
I guess we can get started.
All right.
I'm already recording the meeting. So welcome everyone to the Ontology Summit 2026. Today is the 20th of May, 2026. And this is the first session in the education track of the summit. And we're very pleased to welcome John Beverly, who is at the University at Buffalo and is the director of their programs in applied ontology, both master's and PhD. Uh, he is one of the developers of the BFO standard and is the chair of the mid-level ontology standard working group and has been very active in developing many ontology projects, um, originally at Johns Hopkins Applied Physics Lab, where he has been active in explainable AI, in automated error detection, as well as many other things. So let's welcome John to our summit. John, can you share the screen?
Absolutely. Thank you for the warm introduction. Let's see.
Brief introduction.
No, that's fine by me. I got plenty to say. Can you guys see my screen?
Can you do full screen?
Yeah, absolutely. Full screen. Hmm. Yeah, how's that?
Looks great.
Perfect. Okay, I'll go ahead and get started. So, thank you so much for having me. It's an honor. I'm a longtime lurker, so I've been tracking. And thank you for those kind words. I'm here because I want to outline some of the principles under which, or that are sort of underwriting the ontology education program that we have at the graduate level here at the University of Buffalo. And so, my way in is through, a lot of pain points that have led me to uncovering what I think is a tractable, practical tradecraft that sort of supports that will support the implementation of ontologies and kind of novel ways and push research forward in the community. So I've been in a community for not as long as many folks, but I'm a student of pain, and so it's always been kind of surprising to me that our community has not made more progress. We are sort of feet to the fire now with the advent of AI and large groups like Palantir that claim to be doing work that we're doing on the implementation and operational side, and so. My goal has been to kind of reframe ontology education at UB, really ontology education broadly, as something that intersects directly with engineering concerns. My background is in engineering at the undergrad level, although I have a doctorate in philosophy. So it is a wedding of these, and I do so around tradecraft. So let me get more specific though. So here's a question for you. Here's a question that I posed at Ontobros 2 years ago as keynoting. What distinguishes ontology engineering from nearby disciplines? And these are some of the answers that I got. Ontologists use semantic web stack. Ontologists use OWL. Ontologists build ontologies. Ontologists are concerned with universals or something like that. These are not good answers. Lots of groups, lots of researchers, lots of modelers use semantic web stack. Lots of groups use OWL or something even or like translate into and out of OWL. Lots of groups build ontologies. Lots of groups are concerned with general frameworks like data modelers, conceptual analysis. These are not unique to what we do. It bears emphasizing. So this is what I said to them. It bears emphasizing. We do need answers to these questions. We need to be able to carve off what exactly is what we do that's separate from taxonomies or concept maps or data models or just code, database management, machine learning, etc., and conceptual modeling. And I spent a lot of time thinking about what exactly it is that we do. And there are many reasons for this. One here that's relevant is standardizing training. So we need to target. What exactly is it that we're doing? And so to standardize codify training as we're doing over UB, and hopefully more broadly, we need to know exactly what it is that distinguishes us from these nearby adjacent fields. It's okay that they're adjacent. We don't have to subsume them. But what is it? Is there anything unique about what we do? That's one side. The other side is I've observed over the history of our field, semantic field in general, there are waves and crests of importance, influence, acceptability of ontologies or semantic representations, symbolic representations. It's ebbs and flows. And what happens? What happens over and over again historically? People get really interested in stuff like ontologies. There aren't ontologists or enough people who can do it well. Companies will hire who they can. And then when they put them on large contracts or large projects, they'll pull folks from accounting who have heard about taxonomies in and they'll like populate teams that way. And then when the projects fail, ontologies are just too hard, not worth investing in. And so we hit another, we go down in interest and influence. It's just too hard. We can never do it. So trying to anticipate that, trying to get ahead of that, train people, but also help like procurement folks, hiring agencies understand better what it is they're buying, what it is they're hiring for, so we can avoid that kind of misunderstanding. So when I think about this, what is it that separates us? It's not exactly the artifacts, not the content, not the things that we build, not the product. Let me say more by introducing it with a joke. I love jokes, guys. I'm pretty funny, you'll see. So I used to work at Walmart distribution center. I used to throw freight for a living. I did that until I was 22 before I went to college. This is our break room. We had 15 minutes because Walmart, we had 15 minutes to eat our food, right? And so we would go to this break room and we would like stuff our faces very quickly. So when I first started, I would sit around and there was some group of guys who had been there for a while sitting at the table and they were eating. And every so often one of them would say a number, take a bite of a pretzel and be like two. And everybody would laugh. And so a few minutes later, somebody would say five. Everybody would laugh. So I was very confused. I was new there. I wanted to fit in. So I went over to one of the guys after lunch one day and I said, "What is going on? You say a number, everybody laughs." And the guy told me, he said, "Listen, we've been here forever. We don't have a lot of time. It's 15 minutes to eat. We know all the jokes. So we just kind of like we've mapped the jokes to numbers to be efficient." And so I said, "Okay, well that's cool. That's weird. You're a weirdo, but that's cool. I'm gonna learn the map." And so I learned the map. I spent time studying. And the next day at lunch, I went and I sat down with these guys. And I was just hell bent on fitting in. And I waited for the perfect moment and I said three, and nobody left. Okay, it was really awkward 15 minutes, right? So afterwards I went over to my friend. I said, "What happened?" That was perfect. That was the right opportunity. And he said, "Yeah, you're right, but it's how you tell it." And there's a lot of truth to that. There's a lot of subtlety in what that lesson learned, right? So something about the way I told it. I think there's a lesson learned here. It's how you tell it. This is a trade craft. We're trying to integrate data sets at scale, supporting interpersonal understanding, mission applications, data quality, and governance is roughly speaking what I think we're aiming to do. But we often focus on what it is that we're building, a product. I see this time and time again, the artifacts, the ontology, the things sitting on a repo, things you're sending in an email, the taxonomy, the data model, the code, bag of words, that's the it. We focus a lot on that. We also focus on who's doing it. If you're buying things, if you're working in like contractor space or working for the government, we focus on who's doing it. I want to tell you, that rough idea of a goal I just pointed to, it is not in these companies' interests to solve that. It's lucrative for them not to. And time again, they get big contracts to attempt to solve it, and they don't. So we shouldn't focus so much on the you, I think. We shouldn't focus so much on the it. We got to focus on the how. And this is kind of emphasis that we try to pursue at UB. And when we're thinking about the trade craft, the how, I'm focusing on two main pillars. This is kind of how I guide the structure of the program: interoperability and information quality improvements. So when I'm thinking about interoperability, I'm not trying to give you like a hardcore definition. This has holes, but just as a heuristic, this is what I'm thinking of. Information silos are the targets of interoperability strategies. And these are just repositories, management systems, databases, and whatnot, content of which cannot be easily integrated with that of other information repositories using standard computing strategies. Now, I know, like again, rough. We don't have a lot of time, but there's a lot more here. Like sometimes you want silos, classified information, proprietary information. Sometimes you just want to keep your secrets, right? Sometimes there are good reasons for having silos. Maybe it's the technology can't integrate. Maybe it is a human-human communication issue. Or maybe you just don't know that certain silos exist. I've certainly been in rooms with folks in the government where somebody on one side of the room will say, I wish we had flight records, like a database of flight records. And then somebody on the other side of the room go, oh, we actually have a database full of that. And then the rest is just a rom-com because they met and they were like, oh, lovely. And so, but that happens and certainly in enterprise. Um, this is not news though. Like you guys know, interoperability is kind of the name of the game. One of the names of the game. You understand silos. You understand the data integration problems. It's it's a well-known problem. It's becoming more and more apparent. You see here at the bottom, there's an executive order naming information silos in 2025 as something to be addressed. And of course, if you're old enough to remember 9/11 and the Patriot Act, yeah. So I take it, promise of ontology engineering, at least the promise that I was sold, the one that I'm selling now. They're formally well-defined machine interpretable control vocabularies designed to represent entities and logical relationships among them, and they're designed to address interoperability problems, address information silos by making explicit the implicit meanings buried in data using basic principles of formal logic. And there, in that sense, that's how I understand like making like concretizing or realizing this semantic layer metaphor, which is very itself very ambiguous. And now interoperability, you've heard me say this. I am not going to give you a definition of that. If I've done research, I read a bunch of papers, like I read like 48 papers talking about interoperability, and there were 63 definitions in there for interoperability. I don't think adding another one's going to help. But I will say there are different axes of interoperability that I think it's really important to highlight because they have different conditions of success and different conditions of failure. And when I'm thinking about training students, or the community. I think thinking along these axes has been very valuable. So there's a human-human axis of interoperability. And what is this? Look at these guys, all chummy. It's a social aspect. You know, a couple of years ago, Dolce folks wouldn't be talking to the BFO folks, right? UFO folks would, but human-human interoperability is important. We have to come together and we have to communicate. We have to understand one another. This is alignment between humans. So you often see this through creation of shared vocabularies and definitions and standards and practices, things that you and I ingest, sometimes facilitated by education, legislation, consensus building, etc. Things like joint doctrine hierarchy. If you're working out in the field as a on the ground in military operations, you you better have something you can point to understand what access means if it's being used in a battlefield, or accountability. And they have dictionaries. The DoD has dictionaries. They have doctrine around this sort of thing, something that's standardized so you can move quickly at speed and you can understand what consensus was given. And they're not perfect, they never are. But the central conceit throughout, and you'll see this linking up all the interoperability discussions. This is what kind of connects the axes, is any two speakers, in this case of natural language, share some underlying formal structure. As an ontologist, I often take my job to be finding that formal structure. And it may look a lot different. It often does look a lot different than natural language. And as you'll see, it look a lot different from what you might see in a machine. But that's my goal, finding that formal structure that integrates, that's common. We operate on this axis a lot, I think, at least in the community when we're eliciting knowledge from domain experts, like extracting key terms or formulating competency questions. That is, questions that, stakeholders or subject matter experts might want our technologies to be able to answer, or just evaluating domain-specific terms or content generated by experts. There are dictionaries, thesauri, taxonomies. Wikipedia is a good example of this sort of like interoperability attempt. I mean, they've done a lot of great work recently. I think they warrant applause to that extent. And the success, though, can be measured by the clarity achieved among and across stakeholders, resolution of ambiguities and whatnot, as well as the extent to which consensus is reached. Now, this is just one axis, right? I don't even think this is the axis that brings us to real interoperability at best. Achieving consensus is useful. I'm not always sure it's a good thing, but it is an important axis for interoperability from us. It's worth highlighting. And what we do at UB is we train people to solicit this information from subject matter experts. We train students as an emphasis to work well with others, to develop social skills, to be able to present, but also articulate, persuade, uh, like extract information in a way that makes, subject matter experts feel heard and like they can express their views and thoughts when we record it, right? And so it really is an emphasis that is worth focusing on. Not everybody is a good social butterfly. And so some people are better at it than others. A lot of it can be trained. Everybody in our team, every graduate student gets some training on it, but it is like sort of a pathway you can focus on. You can be the salesperson. Uh, Human machine, though, that's also an important axis that we emphasize. It's the capability of computational systems to interpret our consensus, like what we want to encode, our representations, what we've agreed on is shifting from us into the machines. And you'll see this a lot when we're talking about ontologies or logic models or data models. Like this is where starting to move into the machine. We have to translate this stuff. We have to translate my speak, for example, into what the machine can understand. So, if you're a member of a group and you want to talk about an organization as the sort of thing that must have at least two members, but I want to talk about an organization as the sort of thing that can have at sometimes one member. That's a formal difference between us. Now, a lot of the times we're going to overlap, but representing precisely those differences, that is important, and that is what a machine needs. So it's worth emphasizing. You see this when we're translating, when we're like doing some of the logical representation of things like operations and space control and space support. So those terms, by the way, from that DoD dictionary, and there's a DoD dictionary ontology that Kubrick developed. This has a taxonomical structure and a bunch of logical axioms associated in an attempt, even though, it's written in OWL, it's not as expressive as natural language, attempting to capture as much of the logic of those definitions as possible. It's for machines, though. Again, central conceit, any two heterogeneous information systems share some underlying formal structure, and we are trying to represent that formal structure. We operate on this axis when we're formalizing expert knowledge in machine-readable languages. And like OWL, there's some variations of first-order logic, more or less expressive, or indeed in code, like RDF-lib or Spark or Shackle. We're not alone. NLP folks do this all the time. Cutting edge NLP techniques do exactly very similar things. LLMs are I mean, they're not particularly great at this, especially when you're trying to get really precise, but they certainly help ease the workflow. And so we leverage a lot of those here. We leverage training and using these techniques as well as part of our engineering focus. Progress is often evaluated based on faithfulness of representation and human machine integration. I mean, as well as the extent to which machines can actually extract the useful explicit information that we're expecting. But really, this is kind of it's a bit of art, right? Like you have an interpretation of natural language. How can you capture that formally? And how precise can you get? Like you need test cases, you need boundary cases. It's a lot of logical modeling. And we do that, through our standard languages. We train students to do it as well. But unfortunately, we're kind of pushing the boundaries of evaluating, interpreting, and whatnot. Still, there are some success criteria we have. We know bad logical modeling when we see it. We're developing criteria for what good logical modeling in this sense means. A last here, machine. We also emphasize this. So we emphasize like what exactly is going on in the computational side. So once you have the consensus and once you've encoded it, machine interpretable languages, now we focus on like the interaction between the machines. So this is just focused on this. We get really heavy in the computational and computer science and engineering side. Where interoperability is facilitated through things like JSON LD or RDF or OWL and APIs. But again, the emphasis is the same here, the central conceit that is, any two heterogeneous information systems share some underlying formal structure. Now, it's sometimes, often, a lot easier to see when we're getting to the machine-machine side, but then there are outstanding questions regardless of like what success looks like coherence across translations, alignment of the semantics, and computational feasibility. I think a lot of my research on this area actually focuses on configuration management. So I would never like build a full, beautiful ontology in OWL or any other language and then hand it to a software engineer and say, here are all these edges and nodes, go write code. What I would do is focus on what exactly was needed by a stakeholder or sponsor, and what exactly I had to at best give the software engineer so I can cut a release from that whole cloth, hand it to them, and they can build what they need to. But that kind of lowers some of the barrier or burden of this computational feasibility question while preserving some of the syntactic coherence and semantic alignment stuff when done right. But nevertheless respects the different kind of strengths in a broader workflow of engineering. Software developers do their software development. I build the architecture that hopefully supports well-defined code, and then the stakeholder gets to sit there and play with their GUIs because that's what they really want. So I will point out this was sort of borne out, like the emphasis of these axes was borne out by what I perceived as ontology engineers for many years, conflating the axes and success conditions. It is not uncommon to hear an ontology engineer eliciting knowledge from a domain expert and then trying to teach them how to build an ontology. If I'm in a room and you do that, I will stop you. I don't care who you are. There are different, these are different specialties. I mean, to me, it's no different from having a product manager hire a JavaScript expert to build a user interface for some new product, only for the JavaScript developer to try to teach the project manager how to code in JavaScript. That is how I see it. Like when I go to a subject matter meeting, expert meeting, and I hear some ontologist trying to explain what a continuant versus an occurrent is, like this is BFO terminology, the kind of things that exist in time versus things that exist over time. I usually just intercede. It's like that's we're not training them. We need to understand what they need, right? It's a different expert or specialty. And I know sometimes I'll say this to groups and they're like, who would make such a mistake, John? Who would do that? Lots of people in print. And I see it in practice over and over again. So don't. Just don't. We're emphasizing different group like this in our training. So ontology engineering as a specialty, we have our expertise. And it is an expertise that we respect, and we also respect the domain expert's expertise as well. And so we keep those paths different. Now, if a SME wants to learn, of course, absolutely. But that's not how we default engage them. Um, I mean, there's a kind of another side here. So one other consequence I see of conflating axes. This is where you kind of cater to a subject matter expert's language. I see this again and again. You'll see this when you're, trying to model like a data set and you just kind of take what the data set, the labels of the data set, because this is what the SMEs are familiar with, the language they're familiar with, and you just build an ontology that way. Like, okay, this is what they mean by aircraft. I'm going to build an ontological structure around aircraft. And now I have a class named aircraft, and it's got these specific features. And now if I want to integrate this with another data set, there's another data set and they have an aircraft. It's slightly different logically, but it has the same label. And because stakeholders are often not subject matter experts in ontology engineering, they get confused and they're like, how do we reconcile these things? I mean, there's some straight up ways to reconcile these. That database is defined aircraft that way. The other one's defined aircraft that way. Indexed to the label doesn't affect the logic. If walks like a duck, talks like a duck over here, walks like a different animal over here, talks like a different animal, they're different things from the machine's perspective. You can label it what you want. I don't care. I care what it does. This comes up, by the way, in common interactions I've had working with the government over what exactly a target is or a facility. Some people think, Intel analysts may think, something that is a target is anything you can basically point a weapon at. Other groups think that a target is something material that you can touch. So you can point your target not necessarily at a material thing, even though there are material things flowing through it. It's more or less like an immaterial thing. It's a site, it's a location. But if you mean two different things, you're using the same word and you kind of trying to impose your label on other groups, you're not going to get very far. But I see this happen all the time. And again, there are various strategies that we teach, like kind of practical heuristic strategies for getting around this sort of issue. We're trying to represent the underlying formal structure of the domain while keeping an eye broader integration problems. Labels are not what I want to argue or quibble about. You call your organization that allows for one member an organization. So somebody else will call if it only allows two or more that an organization. If you're using it locally, I don't care. But for me as an ontologist, I will keep them separate because the logic's separate. I'll have a different label for it. I'll use something like an ontologist preferred label, which we use as RDFS label, and it'll say, and I'll have like a feature or comment in there that makes it very clear what the logical division is. Now, you might not see that as a user. You'll see your pref label. You'll see exactly what you need to see in your interface, and that's fine. This is not to say that we should never teach domain experts how to build ontologies or reflect on ordinary or expert language. It's just they are informants, not co-engineers, is the point. I do respect, and we should always respect the domain experts' intuitions and knowledge. I think of it as defeasible intuition. If we stick really closely to an expert's description, we don't, or if we stick closely to a domain expert's definition or descriptions, we don't necessarily owe, this slide should say we don't necessarily owe an explanation to them, but if we deviate, then we sort of need to justify our deviation. And by that, I mean we are able to derive their descriptions from what we're building. My logical model may look very different from the natural language that a subject matter expert might use. But as long as I can derive the way they speak and put that in whatever application they need, that's fine. I have other masters for integration and interoperability. It's the burden that I think an ontology engineer bears. Now, this is just one part. And I think interoperability gets most of the attention in our field, but information quality is just as, if not more important. I think ontology engineering is a discipline that focuses on strategies that simultaneously address information quality or information silos and improve information quality. And I just mean by this fitness of information for its intended use. We see all the bad data. We know data is bad. How do you improve it? There are various strategies to improve information like out there in the world. We're trying to use like semantic technologies and integration logic to help improve the data. And we have to do these things together. If interoperability is pursued without reflection on how information quality will or may be impacted, then we're gonna have trouble improving data quality downstream, vice versa. Like if we just focus on information quality, really accurately representing information and from a database or something, and we don't focus on interoperability, then we're going to have problems downstream. We're trying to integrating this information with other data. This is kind of why we do it together. We've seen the challenges over and over again. We've seen companies, large companies, that sort of emphasize one of these things. And I sometimes you'll see this manifested in the we should have like let's focus on bottom-up strategies versus top-down strategies. Sometimes it's characterized that way, even though that's not exactly how I'm thinking of it here. You need both is the thing. Like I think of it as a pincer movement. Like you bottom up with an eye for the top, so you have a covering semantics. But in any event, like you have to do both. And there are large companies that just focus on one of these. My favorite example, because they're the big dogs and they can take it right now, is Palantir. You know I'm coming for you guys. So Palantir, they focus on interoperability. They hire a bunch of Python developers who write object-oriented code specific to data sets, and they stitch together data sets using their object attribute value models with Python. And it works. Like they can give you a nice little GUI. They can put dots on a map, not accurately, but they can put dots on a map. And that not accurately is an important part because what they're not doing is focusing on information quality. And this is a well-known problem. There's lots of open source publications. I will let you go Spelunk, where people like the Norway Police Department has made it very clear that while they are really good at integrating interoperability, addressing information silos at scale, they are not good at helping them improve their data quality. And why is that? Well, I'll show you. So let me jump through here because I kind of want to get to what we think of when we're thinking of best practices on the information quality side, as that'll make all this crystallized. Now, but before I even get there, I want to emphasize, like, this is not just coming out of John's brain or Barry's brain. Like, there are lots of groups that kind of align with what I'm saying. I think this has kind of been in the aether for a while. There are a lot of foundry efforts, groups that adopt common, like, representation strategies for ontologies or semantics, like the Open Biological and Biomedical Foundry, Industrial Ontologies Foundry, and it says DODIC Foundry. It's actually now called the National Security Ontologies Foundry. That one you probably know less about if you know anything about these at all, because that one is behind closed doors. I work pretty closely with them, but they're trying to create a foundry, principles of ontology modeling that spans the government. And so we've made a lot of progress, but you'll see there's a lot of commonality in here. There's a lot of like requirements, like we respect RDF. We'll try to model things in OWL. We use our IRIs and identifier spaces, versioning scope for our ontologies and representations, as well as textual definitions. This gets us farther downstream than we would otherwise when we're thinking about information quality as well as interoperability. Now, all of these are using basic formal ontology. I'll tell you that. So I'm here at UB with Barry using basic formal ontology. I do not want to get into a fight about basic formal ontology. Our students learn about other top level ontologies. It's less important to me about what the it is and more important about the how. And so I mean, it's natural for us to use this because it's so widely used. It's an ISO standard. It's mandated for use across the DoD and AIC, as you see here in the upper right corner. It's a JESIC standard. It's used by 700 projects, some better than others. So it's not a bad place to start. But one of the main reasons why I think it's not a bad place to start is not because I know Barry. It's because the methodological principles underwriting it have just borne again and again out of time, like aligned with information quality improvement as well as interoperability strategies. So that's realism point. I know Barry's probably come here and talked to you guys to death about realism and get philosophical about it. I'm less philosophical about it. For me, doing realism, when I'm thinking about realism, it's having an external arbiter for subject matter experts to rely on. And when I'm in a conversation with SMEs and I say, listen, I need you to help me describe your domain. I don't mean, and I emphasize, I don't mean what you think about your domain. I mean how the world is. They are a lot more careful. It is good guidance. And I've tested this. They're a lot more careful about what they're describing because there's an external arbiter. I've made it clear to them what I'm trying to get at, that underlying structure across the domain experts. Now, they will tell me what they think, for sure. Their conceptualization, their understanding, but they're a lot more careful and it helps me be a lot more careful about what exactly is settled versus not. I'm not a domain expert often. I'm not a virologist. I don't know what settled science is, but I need them to tell me what settled science is. And there, again, realism, when I emphasize this in practice as a strategy, they're much more inclined to focus on the settled versus unsettled and their conceptualization or pragmatic decisions they've made versus what is more concrete. That's what I'm talking about when I'm training people in realism here. I mean, I do have a lot to say about the philosophical aspects. It's a practical engineering strategy. Hub and spokes too. This is another core feature that BFO adopts, that we adopt too. And I think of this as just basic software engineering best practices. You see this in code all the time, modularization. You see people using a high level on top, like a programming language, and then extending down from it. This is what we're doing too. When we're emphasizing using a top level structure and then extending down, we have strategies for extending down. Again, you plug in your favorite ontology, your favorite suite of ontologies. Like the point is the tradecraft, not the thing. I'm just using BFO to highlight. So there's a bunch of ontologies that sit under BFO and have been extended through certain like well-defined practices for extension. And they integrate together using import structure. And you can use them, you can piece them together, drop them off and add them together and build what you need, and you can extend them. This is to me analogous to using a programming language and then libraries sitting under it. I don't want to go rebuild NumPy or Pandas. I just want to use Python and run it. Now, there's of course a difference, right? Ontologies are not executable. Python is. To me, this is just a challenge for testing. Like, how do you test? Like, how do you know it works? And I have some thoughts on that too. But before I get into any of that, I just want to emphasize, like, I'm not here proselytizing a top level ontology. I'm proselytizing software engineering best practices as with an example of a top level ontology for this sort of enrichment so that we can, because, and I want to hit this too, because this is about information quality improvement, right? Like when I go and I model a database or I go and I work with a stakeholder to model something, they will often miss stuff that is implicit in the upper level structure, stuff that will help make explicit the implicit meanings in data, that will help me stitch together their databases and then pull out information that was there and then help me turn around and improve their data quality. I don't know if you've seen a lot of data sets, but they're often ambiguous. Having a structure like what I'm describing, hub and spoke strategy, helps me disambiguate systematically that data and interpret it in a way that helps uncover nuance, uncover subtleties that the researchers in the domain probably know, It was just so obvious they forgot to draw that distinction. But they're not writing this stuff for themselves. They're writing it for machines, and machines are dumb. They do exactly what you tell them. So you better be careful. Now, for all I've said, I've kind of gestured to this, but for all I've said interoperability and information quality, I've not really said enough to distinguish what we do as ontology engineers from other disciplines. Um, although I've gestured at it, but it's that systematic disambiguation stuff. And I want to emphasize this really hard. So disambiguate here does not mean find and represent a privileged interpretation of some phenomena. It means find and represent the logical space of interpretations. I'm not trying to find one way to interpret the world, whether I'm using BFO or not. I am trying to find out, I'm learning from the subject matter experts, and I am taking seriously the logical space that they're describing, and I'm trying to model that. And I'm motivated largely from my training as a mathematician, where one of the first lessons they taught us was if you get stuck on a really hard problem, translate it into another language and see what happens. Andrew Wiles made so much progress on Fermat's last theorem by doing this. He translated in all these other solutions that didn't work. And then he realized he needed to create a new math to solve this problem. Like, I know how hard that translation is. I want machines to be able to assist me. And for that, I need really careful representations that I can translate a map through and across. So I am on board with lots of different logical interpretations of the space. So I don't want anybody to think that AUB were treating like just one ring to rule them all. I think that would be a bad idea. I think it has been a bad idea. It's not what we're pursuing. It's the rigor, the how, not the it. This disambiguation, though, I'm just kind of highlighting some of the things that I see that are very commonly conflated in data. So obvious, I like to say, so obvious that you will forget to encode it. Types versus instances. These examples, by the way, real world. I've seen this. Algeria is not a class, but I've seen it represented as one. Information versus what information is about. That is probably the most common error I see. An occupation code from ESCO is not the same thing as the thing it's supposed to be about, which is presumably a pharmacist or whatever working. Like one of those things you can touch, another's like a pattern of information. Coordinate systems are separate from the things they're putatively about. And you know this because sometimes your coordinates and targets are wrong. How could they be wrong if they were the same thing? I've had to say this. Information versus what it's about is a very common confusion. Material versus immaterial things, where a river was versus the material things that you see in the river. And processes versus product. This is a little joke for you guys. I told you I was funny. Ontology engineering versus the products, the how versus the it. Again, systematic is the disambiguation of the logical space, principally, locally, logically exhaustive. It doesn't mean boil the ocean. It's more like boiling rivers. But we do build expansive models. We don't give software developers those expansive models. We cut from that cloth. I have this example. I'm going to walk through this quickly because I do want to leave some time for questions, but I just want you to see how we actually operationalize this. Here's BFO and represented through Protege. You see on the left, you see some classes, you see on the right, you see object properties. This is kind of how I teach students to walk through modeling. And you can see, you'll see the disambiguation strategy here. So we've separated off into 7 groups. What are the things you can touch? And you walk through this in sequence. What are the things you could touch? What qualities do they have? What can they do? What do they do? Where are they? When are they? And last but not least, information about all of the above. We save information from all of the above for last because you will confuse it with something above if you don't save it for last. So we save it for last. That example, that question, at what speed does a patrol boat move in knots over an hour? This is a sort of competency question we might receive, a question that a stakeholder wants answered. And so how do we walk through modeling it procedurally? The things you can touch. You don't need to fill out all the categories, right? Usually you have a suite of competency questions, and so you'll end up like satisfying all of this, but not necessarily. If you're just doing it, biting chunks of the elephant one at a time, movement, processing, right? Speed, here's what gets interesting. Remember, logical space of interpretation. Some of this stuff is ambiguous. Speed is ambiguous. You could mean the process of motion, something like a process of increasing speed or maintaining speed, or you could mean information, a measurement of it. At this point, I tell the students, just note that ambiguity and move on. You want to work through the question, work through the list. And if you stop with the ambiguity at any given time, you're never going to make it through the list. So we pause, asterisk, move on. You'll revisit it. That's the next step. So knots, hours also ambiguous. Do you mean the measurement or the thing being measured? Once you've done that, you've walked through the question. We go and revisit the ambiguity. Speed as a process versus information about it. You can mean something like the magnitude of change in position over time, as you see in like a physics textbook, or you can mean the actual changing in position over time. Arbiter, which do we care about to answer the competency question? Now, when we're trying to answer the question, this is what we're focused on. Personally, we model both. But for our purposes here, if we're taking bite-sized chunks of the elephant, what do we care about when we're modeling the competency question? Same thing again. Or after we've made these decisions, we simplify the list for cognitive load, and then we reflect on the relationships across them. And so that's when we get over to the other side of the hierarchy, the object properties, because it's not enough to have classes, we need to connect them logically. And so we have qualities to material entities, realizable things to material things. These are just like, what could this material thing do linked to the material thing itself, the processes that the material things participate in, and then what the material thing could do actually happens. Like, what's that connection? What's that explanation? As well as location, existence in time, and then what's carrying the information of where that aboutness relation between the things and the information. And again, we just walk through procedurally. Patrol boats participate in processes, so there's a connection there. And we walk through each of these, the hours and the speeds, and the hours and the knots, and the measurements, and the motion, and the patrol boat, and all that good stuff. We map out that logical space. And then we get something usually like here's a visual representation of sort of, and you see this in the Common Core ontologies, which is an ontology suite that sits under BFO. You see this sort of design pattern, which would also be represented in RDF or OWL. You see exactly the sort of model there. But this is how we march through, right? Now I began with this question, right? What distinguishes ontology engineering from nearby disciplines? Here's what I'm teaching. Here's what I teach the students. If you disagree, let me know. But let me know now because I'm teaching them this and I don't want to teach them the wrong thing. But it is systematically disambiguating information to simultaneously advance interoperability and improve information quality. Like that, this is the thing. These are the strategies. This is our focus. This is our Northern Star. Now, more properly over here, just to, it's time to do the selling, but like we have this program. We have a master's degree. We have a PhD program. Here's a website here. You can link, I'm linking to it. Go feel free to explore. We got a lot of material. It's fully online. It's fully remote. We have students from all over who are coming and learning this material from us. Here's some of our general learning outcomes. Again, so you can just see you see the human, you see the human machine, you'll see the machine axes represented here. Communicating effectively, right? Demonstrating independence and initiative and research, exhibiting professional ethics, etc. You also see application of ontological methods to domain-specific problems, like graduates demonstrating the ability to lead domain modeling initiatives and also be assessed through domain-intensive electives, working groups like the biomedical engineers over at UB or the management school, like or the computer science department. We allow for lots of transdisciplinary, cross-discipline work because we have a specialty, and part of that specialty is learning how to engage and understand other specialties. We also have, emphasis specifically in our learning outcomes on the ontology engineering process. We have courses designed specifically to emphasize the things that I'm talking about training, like OWL Protege, the engineering side. And we also emphasize an understanding of how philosophy interacts with logic and interacts with the semantic tech or toolkit and where we draw the lines. A little philosophy goes a long way. We don't try to be too philosophical. Definitely have an engineering focus. Here's some of the courses. You can see, and I'm putting this up here because you will be able to see, as I'll point to in a minute, where a lot of these courses are located because they're all online. Videos, GitHub, we have it all available. You can come take the classes and get your degree. You can also just on the MIT model, just come watch our videos and do the coursework. It's all open source, but you'll see you get to learn things like intro to logic for advanced students, ontology engineering, the tradecraft stuff, a lot of which I've been talking about here. Logic for ontologies is a course I teach over there on the left-hand side. That's an emphasis on like software development best practices and how logic intersects with them, as well as courses that expand beyond like the, Barry on my scope, things like biomedical ontology work, computational linguistics, database design for geospatial and et cetera. We have been pretty successful, just FYI. This was our plan. Like we had a goal of enrolling during our first year, just 12 students a max, but we have enrolled 28. Um, this was the first semester. Like this last semester, first semester, we already enrolled 28. We have a class size coming in the next semester of around 50. So already maxing out what we thought we'd be doing. So people are very interested in learning. And as I mentioned, prefaced here, like this course material is online. You'll see it's in the GitHub here under Encore Applied Ontology Education. Um, well, I'm the president of Encore. Barry of the nonprofit version. Barry is the director of the lab portion, the UB associated lab portion, but they are separate entities. But we host all this course material for IP reasons on the open source GitHub organization that is devoted to Encore. But you'll see, like we have our courses here. We have designs for courses on design patterns, certificates, logic, social engineering and knowledge engineering, ontology, tradecraft, intel analysis, and ontology engineering, among others. And these are courses that have full-on videos, syllabi, course like lecture materials in PowerPoints and PDFs, as well as lots of previous students' GitHub submissions because that's how we operate. You do pull requests from our repo, you do your changes, we review them through GitHub because you got to understand version control in the modern era. And so we keep that trajectory, that history. So you can, if you're a student and you're like, I have no idea what to do, you can actually look back on previous students' work, see comments, and learn from what they did so we can continue pressing forward. Here's just an example of ontology and intel analysis. Find the link there. Here's logic for ontologists. We have Slack channels and video, as I said, videos. Feel free to check it out. But now I'm going to pause. I think I have some more time. Yeah, but this is actually my favorite part. So now I want to hear from you about what I said, how it can be improved. And I'm going to emphasize again, I gave you a characterization of what I think the discipline is and what we're focused on when we're training. If I'm wrong, tell me. I'm open to hearing, but also be ready to argue because what do you now? What? Your turn.
Any questions, comments?
Hey,
We do have,
hello. Am I audible? Yeah. Hi. Like
please.
it's always I'm very delighted to like hear John. Yeah, thank you for that. So
Mhm.
my question is like, how do we like quantify the success or failure of like ontology and alignment with
Mhm.
respect to BFO or maybe any other foundational ontology for that matter?
Mhm.
How do we actually
Sure.
quantify it? Because it all for us it all seems very conceptual
Mhm.
and right. Yeah, that's my question.
Yeah, that's a great question. So I think in like traditionally, this has been one of the questions that like people have raised when thinking through, which top level to use. Right. So my answer is I'm not even interested in answering that specific question because I just want you to pick one. And then I think some of those, like you will see some of the benefits insofar as the semantics you inherit from those upper level structures impact your answers to questions downstream, specifically when you're trying to answer competency questions that have been provided by a stakeholder while keeping disambiguation in mind. So if your model disambiguates the data and helps improve the data quality, that's your metric. So you need to be thinking in terms of improving the data quality, uncovering implicit information across different structures, across different data sets. Now, for me, what that means in actual practice, and this would be for BFO or any other structure, it's like how rich is the axiomatization, how rich is the representation, and how well does it answer competency questions? And that's going to be changing by domain, changing by subject matter expert, but really that is it. And we've developed tools over here that work just like that. They rank ontologies based on whether they can answer competency questions and whether they can like avoid a lot of common ambiguities. Now, now that's kind of central. Um, so I wish I had like formal rigorous criteria.
Right, right,
I think a lot of the evaluation does happen at the level of the stakeholder, and stakeholders have different needs. And so because our engineering is focused on satisfying stakeholder needs as well as giving them a representation that they can work, like trust just like you would with code, it really is a matter of evaluating what they're getting. And I think a lot of what I just said you could translate over when you're modeling in Java or Python. How do you evaluate using Java versus Python? Um, how do you? I mean, I know of some ways to evaluate based on exactly what you're trying to
right.
do, but at the end
Exactly.
of the day, how do you model? How do you evaluate that?
So, just a follow-up question,
Mhm.
like uh, if we are talking about the competency question, what the stakeholder wants, are
Mhm.
we like devaluing the realism aspect of it by and
Oh, no, 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 not at all. So here's the thing. Stakeholders talk the way they talk. They think the things they think. They
okay,
believe the things they think. That's real. Like just so realism doesn't exclude. I think sometimes this is confused.
right,
Realism doesn't exclude representing concepts. Like my concepts about how the world is are real. We represent all of them. And so I want to
right,
know what the stakeholder thinks. I just don't only want to know what the stakeholder thinks. Does that make sense?
right, right. That
Mhm.
totally makes sense. Thank you, John. Thank you so much.
Yep.
So Gary is next. Gary?
Yes. So I have a question that's related to the last things you said here. But early on, you distinguished th three axes:
Hmm.
human to human, human to machine, machine to machine. And later on, you seem to emphasize this logical representation. Now, to me, that's the human to computer aspect. You have to make, but the human to human represents more of a conceptual representation, a way of talking to the domain experts as a knowledge engineer. So I'm
Hmm.
just wondering how you incorporate that idea into your later definition of seem to stress logical
Yeah,
as
like
opposed to conceptual.
for me, that's like the key, right? So I want rigor. I don't care what you call stuff. I don't care. I'm never when I'm engaging with a subject matter expert, from my perspective, I'm never being prescriptive. I want like you tell me what you think, what you believe, and I'll kind of guide you in our practice. I'll kind of try to guide you to what, settled science is versus not, or settled research or whatnot, and try to get you, thinking of that external arbiter. But at the end of the day, what's going on as I'm gathering this information is I'm building a formal representation. And I'm building a formal representation using like strategies that I've described here. And then that's always in the interest of putting that into a machine. And like at the end of the day, just to like put cards on the table like as much as possible. When I'm thinking about building these things, I'm really motivated by building a logical foundation for code. So I was once on a project at APL, at the Applied Physics Lab, where we were asked to kind of take a code base and ontologize it. And I don't know if you've ever played with code, but that's a mess. And let's just say we had a lot of smart people and we failed. Now, it taught me early that traceability for like code is often underspecified. Traceability in code is important. And so when I'm building these models going from like what you think, the conceptual aspect into the formal structure, I'm thinking in terms of how do I get what you're thinking into an executable format? And I'm thinking, how can I trace that? So logic is the key. It's the linchpin between them, like formal representations of the linchpin between what you're saying and the code that I can write and trace and explain in a larger code base. I know I said more than what you asked, but I did want to take this opportunity to kind of get the broader picture. But hopefully that answered your question.
Gary? Okay, then our next question is from John Sella. John?
Yes. I've been working in I introduced the word ontology in my
No.
1983. I introduced it to the computer people. Before
Mhm.
that, it was purely philosophical, and the computer guys were talking about epistemology. And it was my 1983 book that changed it and brought in ontology. And I
Yes,
was
sir.
working at IBM, and so that's one reason why IBM has been a very ontology origin group. And one of the fundamental principles, I agree very strongly with the work at the Psych Project, that
Mhm.
that is a group in which they have a top level, but they
Mhm.
don't consider it very important. The most important part is the open-ended variety of special
Mhm.
cases, and that is fundamental. And that is something that I was working at IBM for 20 years, or no, for 30 years, and then had a couple of startup companies. And one of the important points that we do is that we derive the ontology from whatever the people are using. And we
Mhm.
use some general principles. We use the distinctions as the fundamental for deriving the ontology, so that we
Mhm.
have the ontology we derive it from the uh, data that people are using.
Mhm.
And also, we find errors in which they are inconsistent, and we use the ontology derived from their own data to show that there are inconsistencies. And these are the kinds of things that people who are developing the software, no matter what language they're using, they recognize that very importantly, very, very rapidly. And I think that's the fundamental thing, that the top level is irrelevant. The
Mhm.
distinctions that define the top level are important, but
Mhm.
there's an open-ended variety of distinctions, and they may be different for different kinds of applications.
Mhm. There's or one, your reputation precedes you. Very familiar, sir. Two, there's so much that I agree with. I mean, I think I have an emphasis, like, and I've emphasized here slightly different, but really like the central, and hopefully this was coming through to some extent, like a central conceit of mine is formal rigor. Like I want, for example, like if I had my cake and could eat it, I do want formal
Oh,
representation.
formal is important.
Yeah,
Absolutely.
absolutely.
Yes.
But I want like I want as many as I can get. Like, and I want to be able to map between them, like pushing a button style. Like, so I love what you just described. To me, this is like the future. Now, I think we have to, again, we have to bite that elephant in chunks. There's so many different groups representing so many different things, and they're not doing it carefully enough. I've so many times tried to map stuff, and I'm like, you're just not rigorous enough. I'm mapping into nothing, right? And that doesn't help. I'm mapping into natural language and I don't understand the formalization underwriting it. And we can only do that so much. So formal is key. And what I'm trying to do is take like the work that's already existing and have the ontologist over here take the work that's existing under BFO, UFO, Dolce, Psych as well, and identify the overlap because I think all of the diversity of representations is important. It's how we are going to understand novelties, how we're going to make improvements to the data quality at scale, I think. So again, so much that I agree with on what you've said. I think I'm talking about the top level stuff, but really like that's I wouldn't say irrelevant. I think that but the differentiator, as you said, that is important. And I think insofar as we're talking about that, I can 100% agree.
Yeah. Also, I want to emphasize about the problem with natural language. The
Hmm.
idea that what we do is we never assume that what people say in natural language is precise.
That's
What we
right.
do is translate it to logic and
Right.
then translate the logic back to precise English. And we say, is this what you mean? And if
Hmm.
they agree, we're happy. If they usually don't agree, then we have a dialogue in which uh, we generate the formal representation and logic. We translate it to English, which has an exact one-to-one mapping with the logic.
Hmm.
And when we and the customer or the operator or whoever else agree, we're happy. That natural
Yeah.
language and the logic are the fundamental.
I mean, in many ways, I do see as like the engineering tradecraft is getting closer to the kind of work that you and other groups have been doing. So like intersecting and integrating as many of the good lessons that we can from this. So I hear what you're saying is some like complementary and partly like central to what we're doing. So there's not a lot for me to disagree with, really. And I'm glad you brought this up. I appreciate it.
So next we have Jackie.
Hi, thank you. Thank you very much, John. That was a really great overview. My area overlaps with your disambiguation work, so I
Great.
appreciated that you spent a good deal of time sort of explaining that. Now, if I understood correctly, you focus on scenarios that are, I think you used the phrase scientifically stable, and that would have a definable logical space. I have kind of two questions if there's time, and I don't know, if not, just the first one then. How do you describe logically, or have you described logically, when stakeholders beyond the subject matter expert needs to be included in this disambiguation work?
Mm-hmm. So let's see, usually through annotations. Or if like that's the kind of default way. So annotations about like sources and provenance, and also like the needs for more expansion, like heavy documentation on the one hand. Now, if I have projects where I can afford to, and I have been on projects where we could afford to do this, like the actual representations of the differences, the cognitive differences, we can model that too, and we have to do like my work in philosophy, by the way, is largely on like natural language, formal representations like counterpart theory. And so I spent a lot of time thinking about beliefs and wishes and imaginings and like conceptualizations and confidence, stuff like that. And so there have been projects I've been on where we represent like the full gamut. It is messy and hard, right? But sometimes like that's what you need, especially if you're doing like an intel analysis and you're trying to get a bunch of analysts to agree on a certain project or problem or like use case or something, and the stakes are really high. And you really want, if you're making a decision about the aggregation of all of this information, you really want to know what that justification profile is, really in a fine-grained way. And that's, you can't just often rely on annotations or like documentation, even though that's traditionally how it's been done, and like word of mouth and like just trust me, boss. So, I mean, hopefully I'm answering your question, but like it depends on what we have the time or funding to do. But there are some kind of like strategies through documentation that track traditional like processes, as well as the more sophisticated, robust, full model where you're actually able to use targeted reasoning and broader reasoning to pull out information and like have that machine representable. Does that make sense?
It does, and actually, you kind of answered my second question, so thank you.
Excellent. Thank you.
Janet. Go ahead, Janet.
Yeah, thanks. So I think the idea of realism is a stumbling block. I don't see how your whole program wouldn't benefit from replacing the idea of realism with what you said about shared formal structures, because it's the shared formal structures that we want to identify. Now, we can get those by saying what's real, or we can get those by looking at in quantum mechanics and relativity, we can get them with the regularities that we see there, or we can get them in conventions of different disciplines. The question is, where are the standards? Where are the standards? This was the content of, was it last week? Where are the standards? Where can we, how can we justify the standards? Thinking through, questioning the quality of them and their formalization. So realism is like an old idea from where one might have started justifying, but now at a much more sophisticated level, where just I think that could be deprecated, and it's a stumbling block at this point.
So it depends on what you mean by stumbling block. So I've not encountered it being a stumbling block, because like when I'm in conversations with folks and say like the DOW or like just the government more broadly, and I end up talking about standards. The thing that's underwriting the standards is there's some It's the truth, right? And so that comes out, like they vet it, they trust it. And so like that seems to be in my experience something that's fundamental to them. And it is the sort of thing that's supposed to underwrite. Now, partly this is marketing, right? Like partly this is guidance, practical guidance. And this I'm sharing like my anecdotal evidence about the sort of like getting stakeholders into the place I need them so I can uncover that formal structure. But there are too, like areas where they're just not standards you can point to or protocols, where we do have to make decisions about representation or what to represent, but we can't really rely on that. And sometimes we're on the cutting edge and kind of creating the structures, kind of creating novel work or not. Like I have an NIH grant right now where we're like modeling psychological constructs, and it's a mess. My wife's a psychologist. She'll tell you it's a mess, and a lot of it is like novel. And so there's not really standards they can point to. And in fact, the standards they point to often conflict and they're multifarious. They call it the jingle jangle problem. Not sure if this construct using the same label is the same over here. And when it gets down to it, when I'm talking to her and her subject matter expert colleagues, I say, listen, ultimately, like I'm trying to model what's underwriting what's going on. And they know that. They absolutely know that. Calling it realism seems to be helpful. Calling it standards wouldn't be. Does that make sense?
Well, but the thing is that, well, for one thing, the realism, the reality concept issue keeps coming up. And I think that's an unhelpful distinction because, as you said, you want to talk about both. It's not one or the other. But Barry and Jobst Landgrave gave a talk about how the BFO common sense realism assumption breaks down in what is settled science of, as you well know, 20th century physics.
Yeah, right.
So it's not that there aren't standards there, it's that there's no interpretation that points to something and says, this is the reality. There are standards. Actually, the mathematics provides the standards.
Yeah.
So the standards can come from different places. And maybe in your first cut at marketing, you talk about reality. Then you say, but of course, we can get standards from other places as well.
I want to observe what's happening in this dialectic now. So I gave you an example of places where there aren't standards exactly that we can point to. And then you gave me an example of where there were and are making the general claim that there are. And I'm again saying that that is not always the case. So that's one thing. And two, when Barry is talking about realism, and like I'm familiar with his discussion. We were just on the phone about this a minute ago, actually. So he's talking about realism in the sense that like there are no instances that could be called out to in the models that quantum mechanics is supposed to be about, right? And so in that respect, because there's no instance, he's not going to classify it as real. Now that's like the philosophical interpretation of BFO's common sense model. Now I brook no quarry on the philosophical side. That's not when I'm thinking about engineering, not what I'm interested in so much. When I put my philosopher hat on for sure, but as a matter of like strategic guidance for the SME, strategic guidance to like have an external arbiter, like I find it often the case. And again, correct, like if you have different experience, that's great. We need to learn together. But pointing to what's underwriting concepts, what's underwriting our interpretation, whether it be standards or in some cases when there aren't such things like the aims of our science and our inquiry, the real world, I find that very valuable and not a stumbling block at all, although it's not the whole story, and it certainly shouldn't be.
Okay, there's a very specific kind of question about your program in the chat. Will credits from the master's program transfer to the PhD program?
Yes, they are designed. So if you're going into the master's, the master's courses count for the PhD. So, and also I'll add, like if you come in and you are experienced as an ontologist, you can get credit for that experience. There's some question or some exams that you take, like we have to evaluate to make sure that it lines up with the course objectives. But there's a way to get credit comped for your experience in the workplace. We have internship programs as well because we want students to get actual practical experience when they're training, not just kind of like thinking really hard and writing, but like they need to see how engineering is actually done if they're going to make informed like decisions and push research on this.
But that leads to this other question. If you're taking your courses remotely, How do you engage with domain experts?
Yeah. So, I mean, the same way I do, like remotely. So
Okay.
a lot of people in the program, like about half of the students are from the commercial space or government space building ontologies for a living. So like part of the reason it's remote is because a lot of our students are in DC. And so like being a part of the community in the class, you are going to end up working with subject matter experts already who want to be sub SME or who want to learn how ontology engineering works. And because of that, what happens is a lot of the times your face is in the right face and you get connected with a SME, right? Like somebody who's interested in something that you happen to be working on. And suddenly you're expanding your Rolodex by talking to this person who's a subject matter expert who has no care or interest in ontology engineering, but can fill you in on what they do. That's one. And then the other is that internship, right? It's like we do emphasize we want folks to come like to participate in internships where they actually do get hands-on training with subject matter experts. And I'll add too that in core we host an Ontology 101 session, and we'll shortly be hosting a weekly 201 session where for it's a 6 week cycle. 2 of those weeks are subject matter engagement. 2 of those weeks are modeling things in OWL, and then 2 of those weeks are like reasoning and inferencing with OWL. And so we kind of like try to hit these in 2 weeks, like 2 week emphasis over 6 weeks, and then churn folks out so we can drill and drill and drill. But part of that first 2 weeks, and in fact the whole cycle, is that we get subject matter experts from different areas to play the SME for us. So right now we have a SME who's like I forget the company he works for, but they basically like model exchange rates between like exchanges like chemicals that are exchanged or transitions in the economic market between the US and China. And so it's a very complicated thing to model. And their team has been very helpful in like providing expertise so that our ontologists can train on how to model that stuff.
Sounds great.
Mhm.
So I believe that's everything in the chat. Unless, well,
There is
Mike
one
Bennett,
from
are you still
Gary.
here?
We got one from Gary here at the bottom.
Gary and Mike Bennett.
The info.
I don't think Mike
Suitable for
Bennett
form.
is still here.
So Gary mentioned some stuff in Envo that might be more amenable represented in higher order logics. I mean, I don't even think you need to ascend to a higher order logic. Like description logics, or at least OWL, is not very expressive at all. And so there, like I often see us as like providing when we're using OWL as like a starting point for more expressive representations and broader first order logics. And perhaps higher order logics, I often think you can do a lot in, common logic, for example, and kind of simulate some of the higher order stuff. But that's like
Yeah.
advanced coursework.
I might just say a word there.
Hmm.
I've worked on Envo a bit,
Hmm.
as well as other things, and often the definition we have for a term we can express in an axiom, but there's often a lot of context that is added to sort of make some distinctions that aren't part of the formal modeling at any given point, but
Hmm.
might become a distinction or a model later on. That is to say, the
Yeah.
pragmatic aspect of knowledge engineering or ontological engineering is, you're trying to sort of fit to maybe the model will work adequately for this data interoperability.
Hmm.
But there are other issues that come up that would require further modeling later on. And that's not yet part of the formal axiomization. And you put it into the ontology as context.
Yeah. Right. Yeah, absolutely. I mean, ultimately, if I have my druthers, we'll model it all. But having it in there is super valuable. And having that context, and especially for like trying to integrate the modeling that we're doing with LLMs, like the more context you can provide and the more emphasis you can provide on treating this context as like the law, I think the better results you can get, although you shouldn't trust them for many reasons. But um, I get the point, right? There's like edge research going on right now on this topic. So I don't have as much to say about it as a future version of me will, but I definitely take the point. I know John has a lot to say about it.
That point about LLMs is very important because the LLM technology has no ontology whatsoever.
Right.
And they tend to wander around and they can go into terrible kinds of things that lead to actual disasters that kill
Mhm.
people. And the point is that this is why it's essential to have a fixed structure with those precise distinctions from which you have precise logical point. And one of the things is that if you're dealing with banking systems, for example,
Mhm.
you must be precise to the last fraction of a cent. You cannot have anything that is approximately true. And the LLMs are just probabilistic. They're
Mhm.
totally worthless for banking and other applications that must have absolute precision. And this is one reason why some of the things that are coming out of China, that they're new versions that are also started by a bank. The
Mhm.
bank began it, and the DeepSeek system was developed as part of the technology by that bank, which they spun off as a separate entity. So DeepSeek has more compatibility with what precise ontologies are doing
Mhm.
than any of the things that use LLMs.
Right. Great points.
So thanks, John, and all of our participants. That was a very great introduction to ontology education. And we will now move on to next week when Bill Mandrick will be giving talk on Ontology Engineering 101 from expert knowledge to ontological models. So I invite everyone to come next week, and we will continue the discussion about ontology education. So
Yeah.
once again, thanks, John.
Thank you. Thank you
Great
for
talk.
having me. This is great.
Looking
Take care,
forward to
guys.
next week.
Yes, same.